In this chapter, we're going to discuss a few software definitions or concepts which you shall frequently encounter when you study computer science. Your first year and second year course on computers, the emphasis is on software and very little on hardware. Since you're doing computer science, it's more of software. If you do computer engineering, that's going to be a lot more of hardware. Yours is computer science, so you'll be learning a lot more software. In this particular chapter, I am going to talk about what do you understand by system software, application software, high level language, assembly language, machine level language, what is an operating system, what are the different features of an operating system, what all functions does an operating system perform, what are the different types of operating system like a multi-programming operating system, a single user operating system, a network operating system, a distributed operating system, and so on. Before we jump into this chapter, let's take a look at a conceptual diagram to understand the relation between hardware, system software, and application software. The word system and application software was very briefly mentioned in the first chapter. So let us say this center circle represents your hardware. Hardware consists of devices like your CPU, memory, printer, keyboard, scanner, mouse, and so on. Now, everything in the end has to be done by the hardware, like saving the file, reading from a disk, printing on the screen. These are all hardware activities. But hardware on its own cannot do anything. It depends on a software called as the operating system, which is classified as the system software. So, examples of system softwares are operating system, compilers, interpreters, and so on. So, system software gets the request from the application software. Examples of application software are your Word, Excel, PowerPoint, and all. So, when you give a command to save a file in Word, for example, that request goes to the operating system. The operating system, in turn, gets the work done on the hardware, that is saving the file on the hard disk through a software called as device driver. Every device, whether it's a keyboard, mouse, your hard disk, each of the hardware device will have a separate device driver because every device is unique. The operating system cannot have the software to talk to every device, so it uses a software called as device driver to talk to your hardware. So if you look at it, the lowest level is your hardware. The operating system, which is a system software, provides services to application programs as well as users so that the application software can get its work done. Example of application softwares are Word, Excel. Say if I write a software to calculate height of your class, rank of your class, marks of your class, percentage of your class, and so on. These are examples of application software. The best way to remember application, system, and hardware is hardware. Think of the physical electronic devices like the keyboard, mouse, printer, and so on. System software, think of operating system, compilers, interpreters, antivirus softwares, and so on. Application softwares, you can think of Word, you're typing your document in Word, Excel, and so on. So let's first break down our understanding, trying to understand what is this fellow called as system software. Now, system softwares are programs and data which help us control and manage the hardware. They make the hardware usable to the application software as well as the end user. Without the operating system, you would not be able to save a file, you would not be able to read a file from a disk, and so on. So it interacts with the hardware, controls and manages the hardware. The fundamental characteristic of system software is if you have to write a system software, say for example, if you have to write an operating system, if you write an operating system which works on an Intel CPU, the same operating system cannot be taken and put onto a machine which uses an AMD CPU or a Motorola CPU. The reason being the design of the operating system is highly dependent on the hardware architecture or hardware design of that particular computer. Thereby, you cannot port system software from one machine to other. System software has a very close relationship with the hardware because it interacts closely with the hardware. It needs to know how many bytes are there in the registers, how many registers are there, what is the width of the register, what is the data size. All these are very dependent on the particular machine. Therefore, system software is hardware dependent or hardware architecture dependent. You cannot take it from one machine and push it onto the other machine. Now, the advantage of system software is it provides you an ecosystem. It provides you an environment so that you can use your application software to work with hardware easily. As I told you, you cannot work with your hardware without having the operating system. So operating system is an example of a system software. Another example, say you have written a language or a program in C++. In order to run it on the hardware, a software or a system software called as a compiler converts it from a high level language to a machine level language. That code only will run on a specific hardware. So the compiler needs to know the architecture or design of the hardware. Therefore, it provides an ecosystem for application software development and execution. Since it requires hardware knowledge, it needs to be very fast, it needs to be accurate. It is generally developed using C, C++, or assembly language where speed is very important. Examples of system software: operating system, compilers, interpreters, utility programs like your antivirus software, disk cleanup, and so on. So I hope this gave you an idea about what exactly is an system software. System software, in two words, deals and controls and manages hardware interactions for the application software, works closely with the hardware. Knowledge of the hardware is necessary to write it, or knowledge of the system design or architecture, and it's developed using languages like C, C++. All right, and examples I've already told you. Now what we shall do is, let us take a look at what is application software. All right. Okay, best way to understand application software is think of an example. Let us say I have to write a program to keep track of the attendance of all the students, to keep track of the attributes of all the students like their name, address, age, weight, height, class, and so on. This is an example of an application software because I have written it for a specific task or a specific application for a user. Now, when I'm writing such a program, it is not required for me to have any knowledge of the hardware. And the application program written on one machine can be taken to another machine, recompiled, and executed on the new machine without making any changes. So, when you're developing an application software, your knowledge of hardware or architecture is not required or inessential. Example of application software could be your Microsoft Word, Excel, your Tally for managing accounts, database management system for keeping track of all your data. And application softwares are developed using languages like Java, Python, Fortran, COBOL, C, C++, and so on. So application software again depends upon the system software to get the basic services like reading from the hard disk, writing onto the hard disk, printing. It has to put a request to the OS in turn does the printing for you. So application software and system software difference: hardware knowledge is not necessary. This is designed for assistance of the user. It can be moved from one hardware to the other, okay, and it's dependent on the system software to be functional or working. Now let's make a case before we go to the next session. Why do we need computer languages? Language is what? A means of communication between one person to the other or one medium to the other. I'm using language to communicate your first year curriculum to you. Now, why do I need a language? Because without language, I will not be able to convey my ideas to you. Similarly, the computer doesn't understand the language I and you speak. Therefore, we have different types of languages to speak to a computer. They could be the machine language, the assembly language, the high level languages like C, C++, and so on. So languages are nothing but a series of instructions given in the right order to solve a given problem or to achieve a given objective. So these instructions, programs or code tell a computer what to do and how to do in complete detail. Computer is a machine which does not have common sense. It depends on people like me and you to give instructions to get things done.